Okay, so we know how to simplify radicals. We've done adding, subtracting, and multiplying. The last operation is dividing, and sometimes dividing can be tricky, and so that's why we're doing it separately. When reducing radicals, you cannot have a radical in the denominator. So you may not leave an answer. Oh, geez. Let's try that again. Denominator. Okay, so an answer like this, 4 over square root of 5, that is not acceptable. We have to learn how to fix that. Okay, to get the radical, you have to do something called rationalize the denominator. And so rationalizing is just kind of getting rid of it. Okay, so what happens is, let's look at number 1. In order to take the square root of 5, remember, in order to do that, you have to have pairs of something. So I'm missing a 5. So what I want to do is, I want to take the square root of that 5. So I'm going to add another one down here. Well, it's similar to getting like terms or common denominators when you're working with fractions. If I multiply the bottom by something, I have to multiply the top by something. And so now 1 times the square root of 5 is 1 square root of 5. And then the square root of 5 times the square root of 5 is the square root of 25. But we all know the square root of 25 is 5. And again, that's because our goal was to get rid of it, and so we have a pair, so we got rid of it. So the answer for this problem is the square root of 5 over 5. All right, so let's look at number 2. I need another 3, so I'm going to put another square root of 3 on the bottom. But if you put a square root of 3 on the bottom, then you got to put a square root of 3 on top. And so on the top, I get 2 square root of 3. On the bottom, I have a pair of the 3's underneath the root. And so that means I can take out a 3. So that's my answer, 2 square root of 3. Now when I look at number 3, it looks like I can reduce 4 over 10. But you can only reduce things that are on the outside can be reduced with the outside. Inside can be reduced with the inside. So these are not in the same position, so I can't reduce them. So what I do have to do is I do have to get rid of the square root of 10. Well, I need another 10, and so I put another 10 on the bottom, square root of 10. But if you put a square root of 10 on the bottom, then you have to put one on top. And so now on the top, I have 4 square root of 10. And then on the bottom, I had 2 10s. And so that means I can take one out. Now, if you notice, I can reduce it. And so now I need to reduce this by dividing 4 by 2, and I get 2. And dividing 10 by 2, and I get 5. And so my answer is 2 square root of 10 out of over 5. Now again, it looks like I should be able to reduce the square root of 10 and the 5. The square root of 10 is underneath the radical, so it cannot be reduced with something outside of the radical. And so that's the answer for number 3. Okay, let's go down and look at some more. Now when we have a problem like this, oh boy, let's fix that. There we go. So when we have a problem like this, where there's 2 things underneath, you always want to reduce. That's the first thing you want to do if you can. By reducing, you're making your problem smaller and less work in the end. You can always reduce at the end, but again, it's going to be bigger numbers and it makes it harder. So we always want to try and reduce. Okay, so here, 10 and 5, 15, 5 goes into both of those. So I'm going to divide both of those by 5. And so now I have the square root of 2 over the square root of 3. You can break it up like this. It makes it so you know that you have radicals on the top and bottom. Well, now remember, I cannot leave the square root of 3 on the bottom, so I need another square root of 3 on the bottom. And if you put one on bottom, you have to put one on top. And so now this is the square root of 2 times the square root of 3. Those are both underneath, so I can actually multiply. And then here I have a pair of 3's, so it's the square root of 6 over 3. And that's the answer. Change colors. Okay, for number 5, you want to reduce this. And the number that goes into 7 and 14 is 7. And so I get the square root of 1 over the square root of 2. Well, the square root of 1 is just 1, but it doesn't hurt to have the square root there. So we're just going to leave that there for now. But I do need another square root of 2, which I have to put on the bottom, and I also have to put on the top. So that tells me I have one pair on the bottom. Oops, my goal was to get rid of the square root, so I just have a 2 on the bottom. But on the top, square root of 1 times square root of 2 is the square root of 2. And that's the answer. All right, last one. Let's go ahead and reduce this. 33 over 3. Well, 3 goes into both of those. So I end up getting square root 11 over square root of 1. Well, square root of 1 is just 1. And so I just end up with the answer of square root 11. Nothing to do there because I don't have a radical on the bottom. It became this, which becomes that. Okay. Let's do a couple more on the side. There's some more that I think of that I would like you to be able to do. So if you can give yourself some space. Oh, okay. So we just did number 7. Let's do number 6. Let's do 7. Okay, so let's try this. 10 square root 8 over 7 square root 2. Okay, so here's a good example. Let's make it, sorry, I'm going to change this up. Let's make it 70 square root 2. That way we have to do some reducing in both spots. So what I do is I look at my outside numbers. And on my outside numbers, I could divide 10 by 10 and 7 by 10. So 10 divided by 10 is 1. And 7 divided by 10 is 7. But now I'm going to look at my inside numbers. My inside numbers, I can divide both of those by 2. 8 divided by 2 is the square root of 4. 2 divided by 2 is the square root of 1. Okay, well, 1 times the square root of 4, well, that becomes 1 times 2, because the square root of 4 is 2. And this becomes 7 times 1. And so the answer is just 2 7s. So it doesn't look like that's what it should be based on this problem. But by reducing first, you made it a much smaller and easier problem. Okay, let's try one more where maybe we don't have as much reducing. Let's see. So 3 square root of 2 over 4 square root 6. Yeah, let's try that. Okay, I can't reduce outside 3 and 4, but I can reduce 2 and 6, so I can reduce both of these by 2. And so now I have square root of 1, but again, square root of 1 is just 1. So I have 3 on the top, and then I have 4 square root 3. Now again, it looks like you can reduce these, but you can't because one's on the inside, one's on the outside. So now I'm going to add another square root of 3 on the bottom, which means I add 1 to the top. And so I have 3 square root of 3. Here I can take out a 3, so I end up getting 4 times 3, which is 12. Well, now look, I have outside times outside. So now, let's get a whole nother color. I can, not outside times, but outside and outside, I can divide both of those by 3. So 3 divided by 3 is 1, so I get 1 square root of 3. 12 divided by 3 is 4. So there's that answer. So sometimes these answers look totally different than what they should be, but you just do one step at a time. You always try and reduce first, and then you move things so you don't have a radical in the bottom, and then you reduce again.